Welcome to the latest in our series of 80 Schu webinars. In today's webinar, we will discuss how we can ensure our buildings perform better as we aim towards a net zero future and consider what has to change across the industry to significantly reduce our operational energy usage. The context for today's webinar is that we are not even sure yet how net zero will be officially measured. There are many different terms and standards being used by many different organisations. The UK's net zero carbon building standard is still being developed for both existing and new buildings, and we're very grateful to have the chair of the technical steering group as one of our expert speakers today on this webinar. However, one thing is in no doubt: we all need to act now, and all our expert speakers today will give their insights into the strategies you may want to adopt from the client's perspective to the architects and those developing and delivering projects. At Schu, we've set ourselves the target to reduce our total emissions across our business, where we trade in more than 80 countries, by 30% by 2025 compared to 2018 as the reference year, and to stop all climate damaging emissions by 2040. We worked out these ambitious targets with the Worldwide Fund for Nature and its scientific basis confirmed by the Science Based Target Initiative. We understand how critical it is for the industry to deliver a massive improvement in the carbon and energy efficiency of all buildings. So we'll continue to develop products and systems that meet and exceed the highest criteria for net zero carbon buildings. Thank you once again for joining us. I'll now pass you to Ruth, who's chairing today's event.
Thank you, Sean. And yes, I'm delighted to be here because, as you said, this is such an important issue. And it's one we have to not just have enthusiasm for, we really have to understand what we're talking about, how we get there, how we monitor it, and therefore how we learn to do better. We've got a great lineup of speakers, and in due course, we will be hearing from Areti Makantasi at JLL, from James Pickard of Cartwright Pickard, and from Utra Balachandar of Reds 10. I'll introduce them properly when we get to them. But before I introduce our first speaker, I'd just like to make clear to you all that we will be having a panel discussion at the end, as well as some brief questions to our speakers after each of the presentations. And this is an opportunity for you to ask your questions. So please do send them in. And my suggestion is that you send them as quickly as you can so you don't forget what you wanted to ask. Look forward to seeing the questions, but we will now move on to our first speaker. And as Sean was saying, she is Clara Bagenal George, who is the chair of the technical steering of the UK Net Zero Carbon Building Standard. And she does this on behalf of Leti, which I'm sure you know, and which she set up. And in addition, she does have a day job as well. She's an associate at Elementa Consulting, which is an MEP engineering consultancy, and is going to change its name in January when it will become Introba. Clara.
So I'm going to give an introduction to the UK Net Zero Carbon Building Standard, and then I'm going to talk about sustainable design methods relating to operational energy that are common to all net zero carbon aims. I'm going to move on to talk about energy targets and how this relates to net zero. And I'll close with a bit of details on the net zero carbon building standard call for evidence that's going on right now. So what is the net zero carbon building standard? It will be a rule book for assessing new and existing buildings in the UK as net zero carbon. In itself, it won't be a certification scheme, but we do intend that at a later date, a certification scheme will be developed from the Net Zero Carbon Building Standard. It's going to be developed collaboratively. So it's developed by a lot of built environment organisations that have been working in the net zero space for some time. So it's not going to be owned or developed by one organisation. And this is really, really crucial because there are quite a lot of organisations in the space, UKGBC, CIBC, Leti, RBA, that have been putting together targets, which I'll talk more about later. And so the kind of collaborative nature of this standard means that it will be really, really useful in providing clarity to what net zero carbon is in the UK. It's going to address whole life carbon. So this includes setting targets or limits for operational energy consumption and for embodied carbon and some other metrics related to carbon and energy. It's not going to address other environmental impacts, such as air quality or flood risk, circular economy, biodiversity, ecology. These are all really, really important, but the standard's got to focus somewhere, and it's going to focus on carbon for now. It's going to cover a lot of typologies. So it's going to be seeking to cover homes and offices, schools, logistics and warehouses, sports and leisure, retail, higher education, healthcare, science and technology, hotels, commercial residential, such as care homes or student accommodation, and cultural and entertainment spaces, heritage and data centres. But we're only going to be able to develop targets and limits for these typologies if we get enough data that's fed into the development of the standard, which I'll touch on later. It's not going to cover civil infrastructure projects such as bridges. So a key thing is that the targets and limits and other requirements of the standard will be transparently and freely and openly accessible for all in the industry to see and understand, so that everybody can really get clarity on what net zero carbon means. So it's not initially intended that it will be a British standard or an ISO standard, because this might limit access. And crucially, it's going to be science-based, right? It's aligned with the UK's remaining carbon budget and other actions that are needed by the UK's built environment to deliver decarbonisation in line with that 1.5 degree pathway. Right, and that's fundamental to it. So we're taking a really academic and scientific approach to this. It's not constrained or tied to policy. Right, so that gives you a bit of an introduction of the UK Net Zero Carbon Building Standard and what it's for. And now I'm going to change track slightly, and I'm going to talk about some sustainable design methodologies common to all approaches that relate to net zero. And I'm going to focus, as I've been asked to focus, on operational energy. So for buildings to have an ultra low energy consumption, there are some kind of key aspects that you need to cover as architects. So you need to have a simple form, be highly insulated, be airtight, have reduced thermal bridges and such, but I'm going to go into this in a bit more detail. The first one that's really key, and that's really in the kind of arms of the architect, let's say, is form, right? A compact building form is really useful because that reduces the amount of heat losses in a building, which means that it really reduces the energy consumption relating to providing heating. So you can see here some examples of a building with a very large form factor at the top and a much lower, simpler form factor at the bottom. Another key sustainable design principle is about really using that sun, so it's saying, okay, in the winter when I want that heat, let me in. Having windows that the sun shines in the winter, but having external shading, which means that the sun is shaded in the summer, so you don't have overheating in the summer. So again, this is all in the hands of the architect. Similar window proportions. So sensible glazing ratios are really important to reduce heat losses in winter. And so, and depending on which orientation they're on, there's the various recommendations about glazing ratios. I mentioned shading when I was talking about letting the sun in winter, but yeah, external shading is really useful to make sure that buildings don't overheat in summer. Another key thing is natural ventilation. So we want to make sure that buildings can open up and we can let air naturally ventilate through the building, ideally through cross ventilation. And this really helps cool the buildings naturally in the summer. And we need a highly efficient fabric. That means super insulated walls and roofs and triple glazing. So that means that walls are about 500 to 600 mil thick. a bit of a detail here, but the way that you design your balconies can really affect the thermal bridging. So it's really important to think about that and think about that balcony placement. If you put balconies above the window below, that really helps with shading as well. And remember the space for services. So depending on where you have your services cupboard, that affects the efficiency of those services, because if you've got mechanical ventilation with heat recovery, which is recommended to have to provide ventilation throughout the year, it means that you don't have to have this long ducts, which means that you have more inefficient systems. So it's really good to locate that MVHR within 2 meters of an external wall. It's important to have fossil fuel free heating, and really think about the planning of your services. Now, it's important that buildings generate as much energy as possible, and ideally they generate all the energy that they require over the course of a year. And you can design your roof to accommodate that. So really do consider that in design. Okay, so I've gone through a bit about the standard, a bit about some operational energy reduction principles, but how does this relate to net zero? So there are what I was asked to speak about today was about operational energy targets, and there's quite a lot of them out there at the moment. So RIBA have the 2030 challenge, LETI have some energy use intensity targets, UKGBC for offices have energy targets, neighbours have a star rating that relates to energy. So, I think it's really important to say that they are all aligned, so that 2030 target for the RIBA is the same as the LETI energy use target, and it's the same as the Paris proof energy target for the UKGBC, and it's very similar to a 5.5 to 6 star neighbours rating. So they are all aligned, but they all sound a bit different and are phrased differently. And so the key takeaway is that they're kind of all of the organisations that are involved in developing these energy targets are feeding into the UK Net Zero Carbon Building Standard. Another takeaway which is important is that an energy use target or an energy use limit will be a key metric within the UK Net Zero Carbon Standard. So in order to say that your building is achieving net zero, there will be a threshold on the amount of energy consumption that building can use, and that will depend, there'll be a set, the targets will change depending on the building typology. So back to the Net Zero Carbon Building Standard. So the project started in May this year, where we launched, and we invited people from across industry to apply to be involved in the technical working groups. So there's 5 different technical working groups looking at different topics, including operational energy, embodied carbon, top-down budgets, understanding the carbon emissions, the budgets that we have left as part of our 1.5 degree pathway. We've got a group looking at carbon accounting and a group looking at verification. We also have sector groups for each of those 14 sectors that I mentioned earlier. So we asked industry to apply for those groups, and then we kicked those groups off in September and October. So now it's a crucial phase for the project because we're in our call for evidence phase. This means we're asking for data from the built environment industry. We're asking for operational energy and embodied carbon data. I'll talk a bit more about that later. And then in the January time, benchmarks and limits will be developed. The intention is that from summer next year, a draft will be available for beta testing, and the standard will be then finally published in final form at the end of the year. So more about the call for evidence. Why do we need it? Why do we need data? So what we're doing is combining the top-down budgets of understanding the carbon budgets that we've got left with what we're calling the bottom-up performance levels. So we want to understand for all of those different sectors described, what is the average performance level of our stock at the moment, what is the current best practice, and what is the future best practice for operational energy and for embodied carbon. that will then feed up and come, and then we'll blend in the kind of top-down budgets and develop the net zero carbon targets and limits. So that's the intention. We really want to create those targets and limits for as many sectors as possible, but we're only going to be able to do that if we have the data that's fed into the project. So please do go to our website, shown at the bottom of the page here, to find out a bit more about how to give us some data. So what do we need? So for operational energy, we need in-use energy data based on meter readings for best practice buildings. We also need data from energy models, predictive energy models, with some modelers that are available to do some scenario testing in January, and some information on larger operational energy data sets that will give us those sector averages. On embodied carbon, we need data from embodied carbon models, as you'd expect, and some modelers that are available to help do some sensitivity testing in January as well as larger embodied carbon data sets. So as mentioned, we're collecting this data for 14 different sectors, and within those 14 sectors, there are subsectors, don't you worry. So there's a lot of data we're trying to get. So please do share this message widely, because we really need this data. So the deadline for sharing data with us is the 16th of December. So we've got a few weeks left, but we really need to get that quite soon. So please do find out more and visit nzcbuildings.co.uk. Thank you.
Thank you very much, Clara. We've already had a question coming in saying, how can we help by submitting our technical data? So thank you for that link you gave at the end. I think that's the answer to that. So much to think about, but we've just got a brief time for some questions now. And I wanted to ask you, first of all, about electricity, because we have this tendency to say, oh, it's much better to make things electric because it is becoming increasingly renewable. But the key word is increasingly. I can't remember the exact figure, but it's sort of 30-something%, isn't it, at the moment? And obviously going in the right direction. But how do you deal with this in your calculations, the fact that electricity is greenish, but not completely?
So I think what's really important to note with the standard is that we're really looking at what's the carbon budgets that are available in the UK, how much renewable electricity is there now being produced, and will there be from 2050, and that helps understand how we can equitably distribute renewables, because to be net zero, we need all buildings to be net zero, and therefore we need all buildings to be on 100% renewables, but there is a finite resource. We could only build so many wind turbines and so much solar, and that's why the net zero carbon building standard is, the fundamental principles are these energy use limits. So a certain amount of kilowatt hours of energy that buildings can use. And if they use more than that, they can't be net zero. And that has nothing to do with whether they have renewables on the roof or not on the roof. It's just to do with the actual energy, consumed. So that's how we're dealing with the fact that we need to reduce our energy consumption so that it's in line with those renewables.
And you talked about the renewables on the roof. And my other question really was, especially if those renewables are solar, you've got an issue around storage, haven't you? And my understanding is that at the moment, sort of on-site battery storage is still pretty prohibitively expensive, isn't it? Especially given the batteries don't last that long. Just interested to have your insight.
Yeah, so as was mentioned at the beginning, this standard is still very much in development. So we haven't had final discussions on what we think that's going to look like in terms of, will net zero carbon buildings need batteries or not. I imagine they won't, and we luckily we have the UK electricity grid to use as our battery, but we need to make sure that we don't all give it all our renewable energy at the same time that we don't need, because then that means there'll be a kind of grid-wide storage issue. So yeah, it's being discussed and looked at, and there'll be some information on it coming out next year.
Thank you. Lots more to talk about. We'll do it later. And everyone, please do keep sending your questions in. But we are moving on to our second speaker now, who is Areti Makantasi, who is Associate in Net Zero Design Consulting at JLL. Areti.
In today's presentation, we will look at net zero carbon from the perspective of investors and occupiers. We will talk about the business case for net zero carbon retrofits, and we will look into two case studies, one office refurbishment and one office fit out. In June 2019, the UK became the first major economy to commit and set a legally binding target for net zero carbon emissions by 2050. The built environment is responsible for approximately 39% of CO2 emissions, and considering that 80% of the buildings that will exist in 2050 already exist, there is an urgent need for the real estate sector to take action and reduce its carbon footprint. An increasing number of investors are also making net zero carbon commitments and are setting up transition strategies for their portfolios. According to JLL's research, 43% of investors already have set net zero carbon targets in 2021, and a further 28% has set up targets within this year. Therefore, to meet their own net zero carbon targets and commitments, investors need not only to invest in net zero carbon buildings, but primarily they need to roll out retrofit programs for their existing assets. Retrofits, however, are associated with capital costs and potential disruptions of the building operation. So we often do get the question, what is the overall business case behind net zero carbon retrofits beyond the environmental benefits? Net zero carbon retrofits not only lead to energy and operational cost savings, which can be significant, particularly in the current context of high energy prices, but are also found to contribute to additional asset value and enhanced income. 74% of commercial real estate leaders would be willing to pay a premium for leasing a high-performing building, according to JLL's research. Aligning and integrating the net zero carbon interventions within the asset's overall refurbishment plan, capital investment can be optimized through the asset's lifecycle. And finally, meeting tenants' demand for net zero carbon assets also supports the business case for net zero carbon retrofits. Corporate occupiers have their own sustainability and net zero carbon commitments, and therefore they are attracted by assets that meet these requirements. Looking now into net zero carbon retrofits in the office sector in particular, the net zero carbon targets set by LETI and the UK GBC for new buildings have been widely adopted by the industry in the UK. In the net zero design consulting at JLL, we have been working with investor clients who aim to roll out retrofit programs for their existing portfolios. Based on our case studies, whole building deep retrofits are needed for the majority of the existing stock to deliver significant energy reduction in line with the net zero carbon targets. As shown by these case studies here, net zero refurbishments can typically produce at least a 50% EUI reduction in commercial office buildings, regardless of their age or size. And if we look at the central London office example, the 70% reduction in the energy use intensity equates to an annual cost saving of approximately £200,000 and annual carbon savings of close to 200 tons of CO2. Net zero carbon retrofits are not only vital to achieving net zero targets, both individually and nationally for the UK as a whole, but they can also be shown to have significant financial benefits. If we look again at the central London office case study, the net zero refurbishment would lead to an increase in the total return over a 10-year hold period, despite the higher capital expenditure involved in carrying out the refurbishment works. This stronger return is attributable to expectations of reduced letting voids and higher rental growth rates. Looking at the implementation of net zero carbon retrofits, however, is it enough if we only replace systems or lighting in existing buildings? Looking at the whole building EUI reduction, an overall behavioral change is also needed in terms of how buildings are operated and used. And here is a case study of an existing office building in Birmingham, for which we carried out a net zero carbon audit and identified retrofit measures that could reduce the energy use intensity closer to net zero targets. The building was built in 2013 and has a relatively good performing building fabric and a typical building services strategy, including gas-fired boilers and air-cooled chillers. As you can see here in the graph, its current performance and EUI is more than double the target set by the UK GBC for 55 kilowatt hours per square meter. Important to note here, apart from the impact of retrofit measures such as the new HVAC system or lighting replacements that are proposed, are the measures related to how the building is used. The tenant small power and on-site servers are the highest contributors in the overall energy consumption in offices in general. Reducing small power loads would have an impact on how tenants use the space, and I will come to that in the next slides, where we will look at net zero from the occupier's perspective. Additionally, relaxed heating and cooling set points in line with the range recommended by LETI were also found to result in significant EUI reduction. These measures, even though they have no cost for landlords, they would require engagement and buy-in from tenants. Considering their high impact on the EUI reduction, they are key in transitioning existing assets to net zero. To summarize the key messages and takeaways regarding transitioning existing assets to net zero carbon for operational energy, it is important to note that there is a growing demand from investors and building owners to assess their existing portfolio routes to net zero. However, only a few of them have already progressed with implementation. To enable large-scale net zero carbon retrofits, it is critical for the industry to have separate targets for new and existing buildings, for consistency in terms of benchmark targets and statutory requirements to align with net zero ambitions. Behavioral change and engagement and close collaboration between landlords and tenants is also key to achieve net zero carbon for operational energy. Now, let's look at the occupier's view of net zero carbon. Whilst for retrofits, we focus on net zero for operational energy. For fit-outs, occupiers seem to be interested in assessing and reducing both embodied carbon and operational energy that is associated with their fit-outs. And here is a case study of our office fit-out at 20 Water Street, a fit-out where circular economy and whole life cycle thinking were embedded in all stages from concept to delivery. The fit-out has achieved a 42% reduction in upfront embodied carbon compared to a typical fit-out, and aimed for an EUI of 70 kilowatt hours per square meter. This is a great case study to showcase how a design that challenges the norm has a positive impact on both embodied and operational energy. This fit-out provides an active workspace with reduced number of workstations in favor of more flexible collaboration spaces and breakout areas, which are less carbon intensive and less energy intensive compared to areas of workstations. The big ticket items that led to significant reduction in embodied carbon, in particular for this fit out, was the prioritization of reused elements and furniture, with approximately 70% of the total furniture package that came from second life furniture, either from other JLL offices or from the secondary market. And we also aim to maximize the reuse base build MEP system, and also systems that we transferred across from other JLL offices. With regards to operational energy use now and the changes that we have rolled out to all our offices is reduction to the small power equipment and small power load. As I mentioned earlier, small power in offices is the highest contributor in the energy consumption, and therefore we have switched the configuration of our workstations. We have reduced the number of screens that we are using, so we are providing one screen per workstation, and we are already looking at additional measures to reduce loads, such as additional controls to enable floor shutdown when there is a low occupancy day, or additional controls into optimizing the use of the ventilation system, for example, to bring down further the operational energy consumption of our offices. What are the key messages from this fit out, and the key messages that we are also seeing and discussing with other occupiers? Embedding circularity and whole life carbon thinking can have a positive impact, both from an embodied and from an operational point of view. Occupancy density and the percentage of breakout areas versus areas of workstations plays a key role, again, both from embodied and operational energy perspective. Small power load and out of hours energy consumption are critical and should be prioritized as items for opportunities for energy reduction. Relaxed temperature set points in accordance with the recommended range by Leti. It is very important to understand what are the operational energy patterns and what are the key contributors in the energy consumption of its fit out. Therefore, design optimization is key and important, and collaboration between landlords and occupiers. So again, from a whole life, from a whole building perspective, this can bring, can enable net zero carbon targets to be achieved, both for the landlord and the occupier. Thank you very much.
Thank you very much. I think it's really interesting to learn about what can be done within buildings. I think just as we are, just as at one time we didn't look much at embodied energy because the energy in use was so great. Now as things are improving and we start focusing on small power, I think that's fascinating. I just have a worry that people want to get good scores, and that actually building owners can cheat a bit by outsourcing things, you know, whether it's getting rid of their servers and putting everything in the cloud, or, you know, not having any catering, which means that people buy their meals outside, or cutting down on showers. It seems to me that none of those things are actually improving the overall energy consumption, but they're making buildings look a bit better. Is that something you've come across?
Thanks, Ruth. That's a good point that you're raising. However, achieving the net zero carbon targets and the EUI targets set, for example, by the UK GBC for either the building as a whole or for the tenants EUI, it's not an easy task. And understanding the loads and understand the energy consumption breakdown in an office building, for example, we can see that tenant loads are the predominant, and therefore we need to reconsider what is considered today as business as usual model if we do want to achieve the 35 kilowatt hours per square meter target, which is a particularly challenging one for occupiers. The loads need to be reduced first, and this can be achieved by changing the business as a usual model, as I mentioned, but also they need to be controlled in a more efficient way. However, what we have seen in practice is that changing this business as usual model is not always easy and can be a challenge for certain occupiers who, for example, need servers on site for data security purposes, or, for example, they cannot operate with one screen per workstation, because this affects how their business is operating. It is quite critical for them. So it's not always easy to reduce. And what we would like to highlight and what we've seen in practice is that the key parameter is the collaboration between landlords and tenants. Because that's the only way that you can integrate the two elements, the fit out and the base build provisions, and to make sure that they are both optimized, and you can this way you can achieve these challenging targets.
Now, our third speaker is James Pickard, who is founding director of architect Cartwright Pickard. James.
Thank you very much to Architecture Today for inviting me to speak at this webinar on designing for net zero performance. Our mission at Cartwright Pickard is to meet the challenges that matter to people and planet, and we work across housing, workplace and education sectors to do so. We also have specialisms in heritage, retrofit and off-site construction, but also in particular net zero carbon and sustainable design. We are in the AJ 100, carbon neutral as a business, and members of the UK Green Building Council. 25 years of sustainable design. We're in our 25th anniversary year this year, which we're very proud of. And I'd put a number of buildings here, all of which have achieved BREEAM Excellent or better. All of our office projects since the start of the practice 25 years ago have achieved very high levels of sustainable performance. And Solgrave Gardens on the far left there was London's largest passive house project, certified passive house project on completion when that was completed. So we've always been pioneering low carbon design from the outset, and it's been really a key part of our DNA as a practice. It's not a new fad for us. I put this slide up because it's one of our successes in terms of low carbon design over the last 25 years, and has been a key part of our journey. After 5 years of occupation of this building, which is approximately 30,000 square metre office building for the Health and Safety Executive on Merseyside, we revisited the building after 5 years with the client, who was Kojima Partnerships, to find out how the building had performed. The chief executive of the HSE at the time obviously reported the building was achieving very high levels of satisfaction from staff and users of the building, but we also found out that on average over the first 5 years of use of this building, the mechanical ventilation through the displacement ventilation through the raised floors were only coming on for 3 weeks of the year. The building was acting as a fully naturally ventilated building for most of the year, which was quite amazing. And the air conditioning was only being used for 2 weeks of the year, on average over a 5-year period. Now, the impact of that was that the energy consumption, the electric energy consumption of the building was about 40% lower than our best predictions. So this slide shows you the floor plan, typical floor plan, which shows how the extensive use of atria to drive the natural ventilation through the stack effect, the use of openable windows in the top of the atrium roof. And the whole of that principle really drove a highly successful solution that demonstrated that large office buildings can be naturally ventilated for up to 95% of the time. And this slide shows you the use of thermal mass exposed concrete soffits, for example. And also on the right there, just as an aside, we put prefabricated steel stair cores in so that avoiding the need for ladders during construction at all. So it's a very safe construction site. That was part of the philosophy for driving down health and safety risk on the project. Moving on to this slide here, compliance to net zero performance. A key point here is that while building regulations have been updated and there are many different certification schemes out there, we know that there's a need to go well beyond these, because compliance does not mean net zero performance. The RIBA 2030 climate challenge sets out best practice targets for operational energy, embodied carbon, water usage, and several health metrics. But to design net zero performance is even more challenging and holistic in scope. So what do we mean by net zero? It's really important to be clear about the different terminology surrounding net zero, as there are many different aspects, and it's not enough to simply say that a building is net zero. We believe that as architects and professionals in the built environment, we should take steps to contribute, not to contribute towards the sort of greenwashing approach, and we should only use specific industry accepted terminology and make claims that can be substantiated through modelling and analysis. We've recently designed and received planning permission for 2 and 3 Angels Square, which are designed to have to achieve the 2025 RIBA targets for both operational energy and embodied carbon. These 2 buildings, designed for NEPC, will create nearly 500,000 square feet of workspace at Noma, a city centre neighbourhood, a new city centre neighbourhood in Manchester. An interesting element of the design is the inclusion of a modern take on a piano nobile, which is the sort of noble floor, that first floor, where we've lifted public interaction further up into the building. It creates an additional level of public interaction and a link with the public realm at the square level. The design considers sustainability in a holistic way and also takes into consideration aspects of the circular economy, connectivity and transport, ecology, biodiversity, and social value. This image sets out the key elements of our approach to sustainability, not only considering carbon reduction, but also wider issues such as occupant well-being and enhancing ecology. Following a design for performance process, we're targeting NABERS 5.5 energy rating to see that the building will truly perform in use as the original design intent and minimizing any performance gap. The project is also designed to achieve BREEAM Outstanding. So this slide is to try and illustrate operational energy and how it's broken down. And to calculate the operational energy use of buildings, a detailed HVAC energy model has been carried out. The chart that you can see here from Bureau Happold illustrates results of this modelling and the end of the RIBA stage 2, showing how the buildings are designed to meet RIBA 2025 targets for energy use as a minimum. However, there's also potential for the buildings to perform even better than that and meet the RIBA 2030 targets. And we think there is clear potential, and that's shown in the red margin element on the end of each of those bar charts. The facade strategy is fundamental to our approach, and we all see these highly glassy office buildings all over the UK and elsewhere around the world, where style is more important and appearance is more important than the functionality of a building. As architects, we're always looking to take a fabric-first approach to reduce operational carbon. So the envelope is optimized to bring down heating and cooling loads. This is then supplemented by efficient services and offsetting using renewable energy. Key features include high levels of thermal insulation, well beyond building regulations Part L, very high levels of air tightness, good solar control, and inclusion of roof-mounted PVs. And in terms of the circular economy, extensive analysis to strip away unnecessary materials, so in terms of things like internal finishes that we don't need. So focusing on the facade in a bit more detail, we've designed a very responsive facade that balances daylight levels and solar gain in summer. So like a photographic lens will close down when there's more light. Each facade differs according to its orientation. So as you see, the top strip of facade there, northwest facing, which luckily for us faces the main square, we can have more glazing. And then with the southwest and southeast facades, you'll see there's less glazing and more solid. So the facade is highly responsive to its orientation and the solar gain load on that elevation. And we know from past experience that the cooling load in a modern office building, 50% of that total cooling load comes from solar gain, at least 50%, as internal heat gains from computer screens and lighting continues to fall. So any office building that ignores orientation is ludicrous really in this day and age, and there's no excuses for putting style and appearance before this kind of approach to drive down energy consumption of an office building. So looking at embodied carbon from the very early stages, we looked at the various cladding options and ultimately settled for a terracotta tile because of its low embodied carbon, particularly when compared to, say, brickwork or aluminium cladding. Terracotta is significantly lower embodied carbon in that respect. It's also very good in terms of its ability to weather gracefully and have little or no maintenance whatsoever for decades, and we really like that about the material. It's also unclippable. It can be reused on another building when these buildings reach the end of their useful life. You don't have to get a wrecking ball as you would with brickwork to smash it down. You can actually just unclip the tiles, take them somewhere else and reuse them. You can crush them and use them in other forms of construction if required. So there is a degree of recyclability and reuse that comes with them. In terms of the facade strategy more generally, we've analysed the upfront embodied carbon of a typical bay, shown here on the left, a 72 square metre bay. And you'll see that we found that using aluminium frame windows with a high recycled content of aluminium gave us, a significant reduction to the upfront carbon of the facade. So we have assessed every single part of the facade to see how we can drive down the embodied carbon. Now coming on to the superstructure comparisons that we carried out. As a design team, including Bureau Happold and Kundal, we've also carried out comparisons with the alternative structural options and assessed their impact on upfront carbon. Based on this analysis, we proceeded with a post-tension slab with mid-span columns, which turned out to be the most efficient solution, which surprises a lot of people when we compared it with CLT slabs in a steel frame. So In addition to that, we are intending to use 50% GGBS cement replacement in the concrete, which again helps to drive down the embodied carbon of the superstructure. So finally, just looking at embodied carbon and the breakdown of it, this slide shows the upfront embodied carbon and whole life embodied carbon over a 60-year period. Of course, the whole life embodied carbon over 60 years incorporates that upfront embodied carbon element. So what this reveals is that 69% of the embodied carbon emissions occur upfront, 50% of which relates to the superstructure, the frame, roof, and upper floors, and 20% to the external walls and facade. So this reinforces the fact that these are the big ticket items in terms of carbon reduction and assessing their impact. And this has enabled the design team on this project to make more informed decisions and improve the performance of the design in terms of reducing carbon overall. So that's the end of my presentation. Thank you very much. Thank you for listening, and I hope that you got something worthy out of that presentation. Thank you.
Thank you, James. And I love the fact that you came up with a surprising structural solution. I don't know if it surprised you or not, but I guess the question is, do you think too many people are making the wrong decisions because they're not analysing enough and they're going with their guts and their guts are wrong?
Possibly, but I guess there are lots of talented engineers and sustainability consultants across the country working with architects doing their own analysis. I guess one of the key factors with CLT floor slabs is that carbon sequestration is not part of the calculation in terms of overall upfront carbon, and there's a sort of question mark over whether it should be or not. But when you analyse some of the other things you need to do with CLT floors, for example, whether you need a screed on top, the fire protection of it, the requirement for ceilings, etc., and requirements of insurers in terms of fire, all of a sudden, all of these different attributes add up and start to knock it off the first place, if you like. So yeah, we were quite surprised, but the post-tension floor slab solution is incredibly efficient. It reduces the steel, reduces the slab thickness, and we've reduced the cement content by 50%. So, you know, that was all the analysis from Kundal and Bureau-Happold together. So, you know, it's interesting how that panned out.
It is indeed. Again, we'll have a chance to come back to you during our group discussion. Just remind everybody again, please do keep sending your questions in. We're getting some really good ones, but we do need more. But now I am delighted to introduce our fourth and final speaker, who is Utra Balachandar, and she is Associate Director and Sustainability Lead at REDS 10. Utra.
I'm delighted to be here to talk about the strategies in designing a net zero carbon building and how to achieve net zero building in operation. REDS 10 are award-winning vertically integrated offsite contractors pushing the boundaries of volumetric construction. About 40% of UK carbon emissions are due to the construction industry. To reduce this, we must look at the two major parts of the carbon life cycle: embodied carbon and operational carbon. The graphical representation is taken from LITI Carbon Primer document figure 5.1 that shows the breakdown of whole life carbon. We are getting better at building low carbon emission operational buildings, and buildings are becoming more energy efficient, but there are still lots to do with the embodied carbon emissions, as they can represent a higher proportion of whole life carbon. Part of the embodied carbon emissions comes from the construction process itself, and is one of the areas where modular offsite construction can make a huge difference. We are measuring our own footprint and hoping to report on what their emissions are soon. Achieving net zero operational carbon is all about reducing the EUI, which is the energy usage intensity of a building. This could be done by reducing the energy consumptions through the passive design strategies. These includes optimizing orientation and site layout, use of thermal mass and solar shading, and maximizing utilization of natural ventilation and natural daylight in these spaces. Modular buildings can significantly help here through highly efficient fabric and high level of airtightness. Further, supplying energy by using energy efficient systems like air source heat pumps can significantly bring down emissions and remove on-site air pollution. Net zero carbon can be achieved through an energy balance. That is, energy generated on site during a typical year is equal to greater than the energy used. This can be achieved through on-site renewables such as solar panels. The design of the building control system is also very critical to reducing the energy usage intensity in operation. Here at Redstein, we have started to adopt the Class A building control systems. The benefits of this system are that they are fully programmable. For example, this would include control of heating, ventilation, and lighting at individual room level with communication between controllers and a total interlock between heating and cooling and ventilation systems. What we have discussed so far is how we can influence both embodied and operation carbon at the design stage through informed procurement and design. But what about the building in operation? How can we continue to reduce energy usage intensity past the design stage and influence how it is being used? Maintaining building automation and control through ongoing audit and commissioning is critical. The other item which is quite critical is that the data strategy, which delivers the information in a concise and audience appropriate way for efficient monitoring and to diagnose the faults. Redstein have come up with our own approach to minimize carbon emissions beyond the design process. We developed our Thrive platform in a way that made accessible data to all audiences. That is, to help the asset managers build the business cases, school teachers educate students, and facilitate the facilities manager of the building to diagnose faults. This starts with a data platform designed to help building users and operators, maintenance service works off the back of the data platform to generate insights on equipment lifespan based on usage. Dynamic building management is aided by Class A building automation control systems that is installed in our buildings. Energy storage on off-grid management solutions from the data platform also helps us to inform the battery storage needed. All of these operational data feeds into the design process to act as a feedback loop to validate the design and ensure our buildings are net zero in operation. Our Thrive management system helps clients to improve the building performance and reduce energy consumption and carbon footprints. We install Class A systems with IoT devices to surface real-time data from buildings, their internal building control networks, building management systems, and automation systems. We listen to buildings. We provide real-time insights to understand building behavior and operation and inform the decision-making. We run analytics, identify improvement opportunities, and implement controls to optimize building performance. It saves money and it reduces carbon. Here are a few examples that I would like to present. The first example is the NetCap buildings for the Army. All of these buildings we have installed are DREAM excellent and are net zero carbon operational. We have installed our Thrive platform to empower and influence user behavior. What we identified from the platforms we installed are windows are being left open during heating periods, and increased showering also increase water consumptions. Based on these insights, we have educated and are now automating solutions to help the occupants. Installing window contacts so heating and ventilation can be adjusted via the Thrive system. Machine learning is being adopted to decipher the direct energy usage per shower. Giving occupants sight of this information, we also aim to motivate further change in behavior by creating a competitive edge around their user habits. We have collated data and it has helped us to prove the benefits of our work, both in design and also in operation. Annual energy usage intensity at West Town Phase 1 is sitting at 36 kilowatt hour per meter square as of August 2022. This is a 7.72 carbon emissions per meter square rate, which is 78% better than the target emission rate per annum as stated by building regulations. The next example here is Imgen SLA, which is again for the Army. The brief is to provide 69-bed SLA junior office block, net zero carbon in operation, low embodied carbon, BREEAM excellent, designed for off-site construction and also to improve the living experience. For Imgen, we aim to improve on these net zero carbon emissions. We have identified ways we can provide further insight and to drive lower carbon with improved living experience. We are researching to install sensors in the street during the construction stage and delivery of our modules to understand its performance under stress. It will also aid to improve the steel design, which could have desired impacts on embodied carbon figures. Sensors are also going to be fitted to understand the granular level of understanding, such as leak detection. This will allow us to make quick intervention, thus minimizing defects, which is going to also limit the embodied carbon. We want to continue to drive the user behavior and further reduce energy usage intensity. So we are aiming to meter by end use, and we can target individual behavior and hence provide more actionable insight. We are starting to monitoring to the business case. That is, for this hotel style building, we felt it was also important to understand the noise nuisance. So we are monitoring acoustics levels to help feedback into the design and infer user behavior. We are also installing the sensors at external windows and also installing doors, internal door contacts, which is all linked back to our KNX system, which will drive the user behavior. All of the sensors and contactors are linked to heating and ventilation and also lighting of the individual rooms. It further helps to reduce the operational energy. The next example here is the Dinton Activity Center. The project aim is to achieve net zero carbon operational. The measures we used are high performance building fabric, adoption of efficient modular offsite construction techniques, installation of variable refrigerant flow system and add to water source heat pumps for heating, cooling and domestic hot water, installation of solar panels and on roof and also on carports, installation of building metering system. What did we learn from Dinton Activity Center? The lessons learned. The actual performance is greater than the predicted energy usage in the heating months. This could be due to the heating system, which seems to be on even during the non-occupied hours. Smart building controls must undergo frequent checks to ensure the desired performance. Maintaining building automation and control through ongoing audit and commissioning is required to achieve the net zero carbon operational. I would be happy to take any questions. Thank you.
Well, thank you. And fortunately, I have some questions. You talked an awful lot about monitoring and controls and things. I thought that was very interesting and impressive. I know that what your organisation does is it specialises in off-site solutions. And what I haven't quite seen, and perhaps you can explain to us, is how this monitoring and so forth relates to an off-site solution, because it seems to me it would be valuable in any type of building.
Yes, Ruth, you're absolutely right. The technologies what have stated here can be used on other building methodology types to reduce the operational energy and carbon. However, we know from industry studies such as RICS that operation carbon is only one of the challenges on the journey towards net zero carbon, and that embodied carbon accounts for approximately 65% of building CO2 emissions throughout its life. This is where offsite solution is vital on the journey to achieve net zero carbon operational. Breaking it down into stages, such as A1 to A5, C1 to C4, or where offsite construction is unique in its journey to net zero, I would say. If you consider the A1 to A5 stage, which is the transportation, production of materials and construction materials to site, using the traditional construction methods, this would require high quantity of journeys with various different supply chains going to and from to site. Whereas with offsite construction, the supply chain is established and materials, trades, and construction are done in the factory. Essentially, our did, this method we adopt saves approximately 100 journeys to site. Furthermore, with offset construction, the architectural details are standardized. Therefore, any excess material from one project is immediately used onto another, resulting in 100% reuse of material. When you consider the B1 to B7 stage, that is the operational energy to which fabric, services, and renewables, it's all been designed to achieve net zero. The C1, C4 stages, which is the end of life, rather than demolition, by using offsite construction, modules and respective materials can be disassembled at the end of its life and it can be reused on other projects. So whatever technologies I've stated here can be absolutely used in any kind of buildings, either traditional or offsite. For me, like how you consider the operational energy and also the embodied carbon during the A1 to A5 and C1 to C4 plays a significant role to reduce and to achieve the net zero operational building as a whole.
Thank you very much. And I think it's interesting as well to see that, where you are doing a large number of projects for an estate like the military, that you are being able to learn lessons from one and apply it to another. I'm going to invite all our speakers to come back now into a panel. I've had a couple of questions about cost. One particularly aimed at Utra about cost benefit analysis. How easy is it to demonstrate to clients what the effect of additional money spent now, how that equates to money saved over the short, medium and long term? And I think another one that was aimed at Areti, which was asking how you can get people to spend money up front and how near the costs are going to come for net zero compared to more conventional approaches. I think I will put that to, yes, these are the key barriers: initial capital cost in order to achieve long-term costs and carbon savings. Can you discuss meeting net zero carbon, making it close to traditional cost? Areti, I put that to you.
In terms of capital cost increases, it is important to understand, as I mentioned also in the presentation, the business case. So it's not always the case that people have drivers related to carbon necessarily. So capital costs associated with net zero sometimes can perceive the challenges. However, is the overall business case related, for example, to attracting tenants or retaining tenants for longer, or attracting the right type of tenants who are willing to pay premium rents, for example. And there is evidence out there demonstrated by JLL's research that shows that this supports business case towards net zero. However, it is also important to understand that when we talk about net zero carbon retrofits, for example, what measures we are going to implement to retrofit the asset to reach net zero carbon needs to be carefully planned. And if you actually integrate those measures into your typical refurbishment cycle, then actually your increased capital cost is not that significant. So it's careful planning and integration of works that can help you reduce these potential increase in capital costs related to net zero retrofits.
That's very clear. Another question, which actually was addressed to you as well, but I think probably all our speakers may have some input to it. How is operational energy to be proposed as a definable metric if it is not possible to determine the energy consumption of the building user? We've talked a lot about ways that we can save, and I was very interested in all this. let's have only one screen, and the ways that fit outs and things could be done more effectively. But I think I'm going to go to Clara with this, because it must be something that you're having to tangle with.
I think that we can predict the energy consumption of buildings and the users, and it may be that a specific building might be used slightly differently to what you thought it may intended to be, and therefore that's why the energy consumption is different. But we have a lot of data, and predictive energy modelling is quite common practice. So I'm not quite sure I understand the question.
I think the question is, however carefully designed the building is,
Yeah,
how much can you actually calculate
it's
the way
about
that people are
control.
going to use it? It's
Yeah.
control, isn't it? And I think this is what Utra was talking
Yeah.
about when she talked about
Yeah.
people leaving the heating on even when the
Yeah.
building wasn't
So-
occupied.
Yeah, so I like to think about things in terms of control, influence, and interest when you're trying to have impact in terms of operational or embodied carbon. And so as a client or as a design team, you can really understand sorry, excuse me, what you have control over. So you do have control over the facade and the thermal bridging and things like that. You don't have control over how often someone's going to leave the windows on, or if they're going to charge their phones at work, or various things, right? But you do have influence over it if you're a landlord. You can put in place some a bit like a phone bundle, like an energy bundle. So a leaseholder might be able to say, okay, it's cheap rates for if you use this amount of energy, and if you go above that, then there's financial penalties. There's various things that you can do, even if to support energy consumption reduction, even if you don't control them. And so I think, it's important to understand where you're at, what's going on, and how you can influence things in the right direction.
I'm going to start with you again, Clara, but I'm going to move on to some others, because you gave us that very interesting rundown of all the sensible things that one should do for designing a building that will work as efficiently as possible. And I mean, I also like very much, I think it was James that made the point that actually, you need to concentrate on the structure and the facade, rather than making sort of savings in funny little twiddly bits. I know you talked about the glazing and getting sensible amounts of glazing in. I'm not sure if you actually said what one of our questioners thinks that you said, so forgive me for just checking with you, which is they looked at projects that Areti and James were talking about and said, why have you got full height vertical glazing when Clara says you should only have a sort of horizontal glazing strip? I can't quite remember if you actually said that or not, but how sort of dogmatic were you about that? And then I'm actually going to go on to James and to Areti and ask them about it.
So I probably didn't say that, but the diagrams on the slide may have recommended some glazing ratios, and the Leti. So all that section was taken from the Leti guidance, and Leti has guidance on how to most cost effectively have energy have your energy space heating demand as low as you need to meet the Leti targets, and having glazing at the right size so it lets some daylight in but it doesn't let the heat out, shading so that it doesn't let the heat in when you don't want it is the best way to go about it. But there are other architectural reasons why you might not do that. So I would rather, I'll let those others explain.
Yes, I think I'm going to go to James, because you've obviously put at the Angel development, you've obviously put a great deal of thought into the facade and into the glazing. So I wonder how you respond to this questioner who says, "Ooh, you've got full height glazing, and really you shouldn't have."
Yeah, I mean, it's a good question. I think with residential design, then the optimum is obviously to avoid glass below a sort of sill height. Well, not avoid it, but not be excessive with that. But I think what we've done at Angel Square is We've got average probably about 40% glass to solid insulated envelope around the whole building. And with office buildings, we treat office buildings differently to residential buildings because they have very deep floor plates compared to a residential scheme, or deeper, let's put it that way. And what's important from a wellness point of view is not only the daylight levels, but also the ability to see outside and have visual contact with the outside and the diurnal changes and things like that. We've learned over many years of designing office buildings that if people away from the windows feel cut off from the outside, then that's not an optimum position for them in terms of an occupier. So it's balancing the ability to see the outside and the contact with the outside and daylight, and optimizing that with heat loss and solar gain. But as I said, the facades, we've been very careful to model those and optimize each elevation and tune it to work with its with the solar heat load. The facades also do show what might look like glass all the way down, but there are some insulated panels at sort of sill height in some of those glass areas to get that optimization. So although the images, CGIs might look like floor-to-ceiling glass in some locations, there is in some locations, but not everywhere.
Someone's challenging your assertion about terracotta being a less energy intensive material than brick. And they said, well, brick can be a structural material, whereas terracotta is just a facade that needs a structure behind it. Now, I very much doubt that you'd be building anything like that in load-bearing brick, would you? But I'll put the question to you and let you answer it.
Well, it's interesting, and I've got nothing against brick, but you only need to Google, look it up yourself, and you can see how high in embodied energy the manufacturing of bricks has become. And lots of the sort of illustrious architects in the UK are using bricks manufactured, in Germany or wherever. And if you add in the shipment costs of that as well, it really goes off the Richter scale. Yes, brickwork can be load bearing, but the facades, the external facades of most residential buildings in Britain, that external facade is not load bearing. It's supported off the frame, or it's supported off the inner leaf, which might be a prefabricated panel or blockwork or something. So the external face of brickwork is very rarely a load bearing, other than carrying its own weight to the shelf angles that are taking it back to a frame. We've done our research, and the terracotta tiles have, I think, less than half the embodied carbon of brickwork, depending on where you have the bricks manufactured. We also feel that because it's dry construction, it's much faster, can be done more safely. If you look at the shortages of skilled labour in the UK, bricklayers are in very short supply, very expensive, and about 10% of them leave the industry every year due to dermatitis. It's a big health and safety issue in Britain. So I think we just got to be open to look at alternatives. And at the end of life of a building, the terracotta can simply be unclipped and used on another building. It's got a very long life and requires little or no maintenance through its life. And if ultimately it needs to be recycled, it can be crushed and used as aggregate in the construction sector. So we feel it ticks a lot of boxes for us.
And it's interesting that you talk about the way it can be reused and its end of life, because someone's come in with a question about the end of life use of post-tension floors. Aren't they more difficult to demolish than other types of floor construction? And did you consider this in terms of the reuse of building materials?
Yes, and it's just one of the many things that you have to weigh up when you're trying to drive down the upfront carbon in a building. And I think quite right, you are going to have to demolish that ultimately at the end of life of that building. But what we've tried to do is we have got quite generous floor to soffit heights and quite reasonable spans, the frame structure. So as we've done with other buildings, we feel we built in a longer life into the design. So this building could in 30 years' time could be turned into a residential scheme, a hotel project, a university building, could have all sorts of different functions at some point in the future because of the additional floor to soffit height we've given it and the floor loadings, etc. So I think we've got to look at buildings as assets that have got to be here for a lot longer than typical commercial buildings in the City of London, for example, which are knocked down after 30 years. So that's how we've been looking at it. And in this case, we have looked to drive down the upfront carbon in the frame, foundations, and facade.
Well, I think we'd all agree with most of that. We've all been talking at we've got an expert panel here, and we've got a great deal of knowledge, and we've got a question here that reminds us that not everybody has the same level of knowledge. Somebody said, "Oh, I've worked with many architects who still don't know how to calculate a U value or what thermal bridging is." How's the education of design teams going? Now, Clara, I'm sure that part of your concern in setting up LETI, etc., was to increase knowledge, not just of the problems, but also the details of how one deals with them. And I just thought it would be interesting to have your insight into partly the state of knowledge and also how you think it's advancing and how people are coming to understand the things they need to know.
I think the industry is improving. I think, you're right, that is partly what LETI was trying to do by involving people in the discussions about how we need to move forward, how we need to make change. We are upskilling a lot of people. So, and by producing useful guidance, we are also, again, providing resources to upskill. I think there's a lot of, in my experience, it's difficult to know because I typically talk to and surround myself with people that know a bit more about the topic, I think, because that's why they're speaking to me. So I'm probably actually not the best person to reflect on that. I have been the external examiner for an architecture course at Nottingham University for the last 5 years. And from what I understand in the architectural education, most schools are providing a lot of useful support and teaching on this topic. So for the younger architects, I think it should be covered.
There's another question here for you. Someone's saying, is there a reliable way of calculating kilowatt hours per metre squared per year, apart from PHPP, which is the passive house calculation tool?
Yeah, so CIBSE has a useful guidance called TM54. And it's a method for calculating predictive energy modelling. And you can use various tools to do that. So PHPP is a tool, and IES is a tool that you can use to calculate predictive modelling, but predictive energy, and then you can divide that by the floor area to get the EUI. I would say, though, the tool used really depends on the typology, and my suggestion for residential is to use PHPP. It's much a simpler and quicker way of doing it than modelling in IES, but other consultancies really like to use IES for Resi as well.
And they should do it in the way they enjoy. I've got another question, which also came in initially for Clara, but I think someone else sent in a similar one. And this is around location of buildings, how much... and I suppose I'll start with you because obviously, you're working on this standard. Is how much are you looking, or should we be looking at things like ease of access by public transport, etc., in terms of building location, which certainly will feed into the whole carbon budget of the building and its users. But it's obviously a tricky one to incorporate.
Yeah. I mean, where you draw your line of scope and of boundary is, is really tricky. In the Net Zero Carbon Building Standard, we are not considering the carbon emissions associated with the transport of the users of the buildings within that scope, because it's not. Yeah, the standard doesn't really help you say where you should locate your building, and in the kind of top-down budgets that we're calculating what what the carbon budgets are for the buildings and dividing that through so that we can work out what net zero means, we're not using the transport budget for that, we're just using the buildings budget. So we're not covering it, but it is important.
And I'm going to put that to Areti, because I wonder, with all the increasing awareness that you say that clients have about the environment, about energy usage, how much are they actually looking at location and at transport options?
Clara also mentioned that this falls into the wider sustainability or ESG agenda. And what we have seen is that more and more clients, investors, and occupiers are setting up their own ESG targets. And there is quite an interest in the industry trying to understand how organizations within the real estate sector in particular can reduce their impact. So this would fall as one of the main parameters that we would look at if we were going to develop an overall sustainability or ESG strategy for a client.
I think, James, sorry, I think I missed you, but I think you wanted to come back about something, didn't you?
I think it was the question on the training and education of architects
Yes.
and architectural students. So obviously I interview people regularly. I think in our 25 years, we've put through the part 2 to part 3 in qualification over 60 people and who've all qualified. So we have a 100% success rate. But what we still see is a deficiency in the understanding of sustainability and design and environmental design issues. University of Nottingham, actually where I studied, I did a degree in architecture and environmental design, is a leading school in terms of environmental design aspects of architecture. But I do think that, and I know it's always unpopular to be seen to be sort of knocking the educationalists, but there is still a real disconnect between those that teach and the world they're in and those that are actually doing it and actually having to deliver buildings. And there is still a huge disconnect. And it's why government has instructed the ARB to get onto architects to improve their upskill themselves in terms of environmental design and also, as we know, fire and facades. But there is a lot to do, and I think the RIBA could be more effective in driving change in schools of architecture. It needs to happen very quickly, and I guess what I'm saying is it's not enough. We're still interviewing students who've got 2 degrees in architecture or a degree and a master's, and their understanding of sustainability and environmental design is woefully poor. It's still happening. So there needs to be great improvement in the education and training of architects, in my humble opinion.
Thank you. I'm going to go to Utra briefly, because you're obviously dealing with all sorts of people. You're dealing with large client bodies, and I wonder how much understanding you feel there is now of the issues.
I think there is a greater deal of understanding by the clients. We engage with clients very early in the projects. We go through the design stages from concept design. We run through workshop with our clients to understand their sustainability requirements and what is required in the design to achieve the sustainability targets of the project, which is both embodied carbon, operational carbon, and also how to achieve the operational carbon in usage. With all the lessons learned from all of our previous projects, by installing all the monitoring and controls, we also share the lessons learned with the client in the current and future projects, which is really making a great deal of the difference.
Well, I think you've all been sharing lessons learnt with us as well. I've certainly found it not only educational and interesting, but I have to say fairly cheering as well, because we have to a great extent been talking about solutions rather than problems, and I think we all know how massive the problems are, but it's really great to be talking about how we get there, both in the larger scale of setting standards, in terms of great design, and also in monitoring and right down to, I think, sort of controlling behaviour, which seems to be a bit of stick and a bit of carrot. We have come to the end of our time now. I'd like, first of all, to thank all our audience, both for being an audience and for all the really interesting questions you sent in. I would like to thank all our speakers who, as you know, have been fantastic, and to thank our programme partner, Schu, and on behalf of Architecture Today, to say thank you very much indeed. Look forward to carrying on and debating more subjects. Thank you all very much.